1 plus x squared to the power of 10. Okay, first four terms. Let's go. First one. 10 choose. 0, 1 to the power of 10 x squared to the power of 0. Do we need to write all this down? Oh, seriously, do we need to write everything down? We know that this is actually 1. This is 1. This is 1. It's just 1. Okay. So 1 plus. Now 10 choose 1. Okay. 1 to the power of 9. Do you bother writing 1 to the power of 9? Don't bother. Okay. Next one is x squared to the power of 1. Okay. Don't need to write x squared to the power of 1 also, right? And we also know that 10 choose 1 is simply 10. Okay, so I got two terms already. Okay, third term. 10 choose 2. Okay, 1 to the power of something, don't bother writing down anymore. So now I've got x squared to the power of 2. Fourth term, 10 choose 3. X squared to the power of 3. Notice all these brackets, they are very important. All these brackets over here. Because we are squaring the entire x squared. My x squared is now, my b is now my x squared over here. Okay? So I'm squaring the entire thing, I'm cubing the entire b, which is x squared. So are these my first four terms? Do I leave it like this? Yes, plus dot dot dot. Okay, so now let us attempt to simplify this without using our calculator. What is 10 choose 2? How do you get it so quickly? 10 times 9 divided by 2. 90 divided by 2 is 45. 45 x to the power of, what is our a to the power of m to the power of n equal to mn. Okay, so here we've got x to the power of 4. Okay, next one. 10 choose 3. Mental subs, come on. How much is it? How much? 120. How do you get 120 so quickly? Okay, let's try to do it mentally. 10 times 9 is 90. 90 times 8 is 720 divided by 6, because 3 times 2 times 1. 720 divided by 6 is 120. Okay? So that is 120 x to the power what? 6 plus dot dot dot. Okay, now I've got my first four terms. Alternatively, if you don't want to multiply everything out, we can actually cancel. Okay, so 10 choose 3 was actually 10 times 9 times 8, 3 times 2 times 1. Many things to cancel, definitely can cancel. 3 and 9, 2 and this becomes 4. 120. Okay, you can do this mentally, also can. Yes? We want you to practice your mental sums also, because you will see questions during your tests and exams that doesn't allow you to use the calculator. We'll design the question such that you want to use calculator, also cannot use calculator. I don't even say you are not allowed to use calculator in the test. You want to use, also cannot use. Okay, if I don't show you the question during our homework, you remind me I show you one question during the test. Okay, so now, second part. Use your result to estimate the value of 1.01 to the power of 10. Now, 1.01 to the power of 10. If we were to do this without calculator, without binomial, what will you do? 1.01 times 1.01, is it? Then you get the answer, and then you times 1.01 again, you do it 10 times, right? Obviously, this is very tedious. Obviously, it is not the best way to do it. So if I want to do it without calculator, without multiplying everything out, we go back to the first part of the question. Do you see any similarities between the questions? Okay, what are the similarities? Yeah, we see a power 10, isn't it? So if, and it is not a coincidence that there is a power 10 over here. What do you think they are trying to get you to realize? Okay, they are trying to tell you that 1 plus x squared is it should be equated to 1.01. So, you say, let 1 plus x squared be 1.01. Because once we manage to do that, I can make use of my binomial expansion, which I'll show you later, to get an estimate of the value of 1.01 to the power of 10. Okay? Now that we let 1 plus x squared be 1.01, Can you tell me what x squared is supposed to be? Oh, if x squared is 0.01, what is x going to be? 0.1. Okay? Now that I have x to be 0.1, and I look at my binomial expansion, okay, all these are, this is supposed to be 1 plus 0.1 square to the power of 10. Can you see the similarities? X is now 0.1, right? Okay. Now if I were to expand everything out, in blue color, what do you think 1.01 to the power of 10 is going to be? What is it going to start with? 1, because there's no x term, right? It is simply 1. Plus, what do I write next? 10? 0.1 square. Okay, at this point in time, any questions? Because I simply let x be equals to 0.1. Okay? Now, mental sums. 0.1 square, how much is that? 0.01. Is it a big or small number? Small. It's quite small, 0.01. Okay? Let's continue. 45 times 0.1 to the power of 4. Okay, mental sum. 0.1 power 4. How much is that? 0.00001. Okay, so it gets bigger or smaller? Smaller. Is it significantly smaller? Yes. Yes, right? Okay. What about the next one? 120. Wow, big number. 120 is a big number, right? Okay, what about x now? 6. 0.1 power 6. 0.1 power 6. Is that a big or small number? Small. Extremely small. Right? It is, in fact, 1 divided by 10 to the power 6, which is 1 divided by 1 million. 1 divided by 1 million is very small. Okay, let me just write it down over here. This is the same as 1 over 1 million. Then you have a 120 multiplied by 1 divided by 1 million. Is that still a big or small number? Small. Still smaller. Okay? Can you imagine now? There's a plus dot dot dot, right? Subsequent parts, what do we have as the power for the 0.1? What is going to be next? 20. Are you sure 20? The next one, immediately next. 8, right? Then, is that big or small? Small. Still small. In fact, it's going to get smaller and smaller and smaller, such that, are they significant? Yes. Why are these small numbers significant? When I ask you to round off to 3SF, for example, all the little small numbers at the back, you don't want them, right? Because they are insignificant. So now that I have 0.1 to the power 8, it is even more insignificant. Okay, we can throw all those away because they're such tiny numbers. And eventually I'm going to ask you to round off to 3SF. So yes, we're going to have all these plus dot dot dot, but keeping in mind that all these are insignificant. Okay? So now hence calculate use a result to estimate value, blah blah blah. Okay. So this is what we have. I am going to transfer this to the bottom. Okay, so now it's the time to estimate. 1 plus 10, 1 over 100 plus 45 over 120. Okay, so from here, you can use your calculator already. Because I'm not going to, I can expect you to do it lah. So this is 1 plus 0.1 plus 0.045 plus 0.12345 1.1. Are you sure? Oh, 0.462. Okay. Now use your calculator. 1.01 power 10. 1.10462. Yeah. So you see how it works? Are they equal? Is this equal to this? Why would you say I rounded off? Yeah, because there's still a dot 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 at the end. Right? So they are not exactly equal. I am rounding it off. Okay, so this is for question practice now 12. Okay, last about 15 minutes. No need, you can leave it like this. Yeah? Why do I want to square root the x? I am letting x be equal to 0.1. I'm not trying to solve for x. Do you get the same answer? You can show it to me later, yes? No need, you can leave it like this. Okay? Exercise 3B. Okay, which other questions you want me to go through? 2B. Wait, 2B first. Find the term, okay. X over 2y plus y squared over x power 12. They want the fourth term. Okay, so TR plus 1. 12. Now I need you to fill in the blanks for me. Class. Stop talking amongst yourself. Here, what is the general term? For this type of question, always write down the general term first. Okay, so TR plus 1 will be n, which in this case is 12. Choose how much? R. Okay, what is my value of A? X over 2y. So what is the power for this A? 12 minus R. You can write n, but you must know that n is equals to 12. Okay, next, what is the B term? Y squared over x to the power of R. Okay, this is my TR plus 1, my general term. Which term do they actually want? They want the fourth term, right? So what is the value of R? 3. You need to, this is why I asked you to write down the general term like this, so that you don't make the mistake of thinking fourth term means R equals to 4. Alright? So we know that it is equals to 3. So 12, choose 3. X over 2y to the power of 12 minus 3. How much is that? 9. Y squared over 12, that's over x to the power of 3. Okay, 12, choose 3. Yes?
So the TR plus 1 is the general term, right?
Yeah?
For all the things, right, TR plus 1 bracket n over n choose R bracket A n bracket. That one, what is that called?
General term lah. This is the specific general term to this question. That is the general term to A plus B power n. This is the general term to x over 2y plus y squared over x power 12. Okay? So now, 12 choose 3. How much is it? 12, 11, 10, 3, 2, 1. Okay? Yeah, I can cancel. 3 and 12, 4. 2 and 4, 2. So, 2, 2, 0. I am not. So 2, 2, 0. What is the power for x? 9 divided by 2 power of 9. Y power 9. Don't forget your indices. Okay, y to the power of how much? 6 divided by x power 3. Now we cancel. Okay, so let's cancel what we can. X power 9 with x power 3. What is left? X power 6. Y power 6, y power 9. Cancel, what are we left with? 3. 2 power 9. 2, 2, 0 divided by 2 power 9. So I need to use calculator. 2, 2, 0 divided by 2 power 9. So that is 55 over 128 x to the power of 6 divided by y power 3. This is the answer? Yeah, okay, that's it lah. Okay, next question. What do you have? Which question do you want me to show you next? 8.
I need 4A.
4a.
I don't really understand the term.
Hey, what is term independent of x? What does it mean? What do you mean 0? Power of what is 0? power of x is 0 means the x disappears. There isn't such a term anymore. Okay, so again, when you have term independent of x, when you see this term, straight away write TR plus 1 and let power of x be equal to 0. Okay, these are the steps you need to do. So, TR plus 1. Okay, come, let's start quickly. What choose what? 6 choose R. X squared to the power 6 minus R. 2 over x to the power R. Okay. So there is a certain term that has no x value. For that certain term, it has a certain value of R. Do you know the value of R yet? Don't know yet. Okay, never mind. Let's leave it as 6, choose R. Now, we want to group all the x terms together. We see that there's an x over here, there's an x over here. Okay, so we're going to use indices. For the first one, x to the power of x power 2 times 6 minus R. Okay, so indices are. Next one, 2. 2 is a number. 2 power R. And then I've got x again, right? X power. Wait, we've got 1 over x. That is rewritten as x to the power of negative 1, yeah. And to the power of R. Okay. So negative 1 over here to the power of R. Can I combine everything together? What would that give me? Darius, what would that give me? X power negative 1 power R. No need to look at your paper, look at the screen. X power negative 1 power R. X power negative R. Okay. So we rewrite this to become x power negative R. And now I see that I should combine my x terms together, right? Okay. So 6 choose 2. I put all my numbers on one side first. And I leave my x terms at the back. Okay, so now x to the power of 12 minus 2R. What's next? What's next? Oh, sorry, 6 choose R. Yep. Okay, 12 minus 2R. Minus R. How much does that give me? Okay, 12 minus 3R. Let me rewrite that because it's just simply mental sums. Minus 3R. So you see, our general term looks like this. Every single term, if I were to expand it, if I were to expand this, I will have many terms. In fact, I have 7 terms. Okay, because power 6. So every single term it has this format. Whether it's R equals 0, 1, 2, 3, 4, 5, 6. Okay? So now there's a particular term where x disappears. Because they say x, the term is independent of x. What is the particular value of R such that x disappears? 4. How do your friends get 4? Okay, you guys are right. Like I said, let the power of x be equal to 0. This is my power of x. This is the step where we let the power be equal to 0. Do not let, for example, this be equal to 0 because it doesn't do anything. Do not let this be equal to 0 because it still doesn't, it's not the overall power of x. Okay, so only the yellow one works. So we let 12 minus 3R be equal to 0, therefore R equals to 4. So you substitute the value of 4 inside. So T 4 plus 1. Which term is it? Term 5. Equals to 6 choose 4. 2 to the power of 4. X to the power of 12 minus 3 times 0. Why bother writing it down, right? We know it's going to be 0. Okay, by write it down just to show you anyway. Okay, 6 choose 4. Wow, so fast. 6 choose 4 is actually the same as 6 choose 2, right? Symmetrical, 6 choose 0, 6 choose 6, 6 choose 1, 6 choose 5, 6 choose 2, 6 choose 4. Get it? Yeah. Okay, so 6 choose 2 is much easier to work out, right? How much is that? 3 times 5, 15. Okay, so that's 15 times 2 to the power of 4, which is 16. X to the power of 0 lah. Okay, so that is 15 times 16. Okay, 240. So you see, the x disappears. This is the term independent of x. Right, next question. What did you want? 8. Okay, I guess I only have time for this. 2 minus x to the power of 4. Find, expand. Okay. Yeah, you need to write down all 5. Show me your answer. Somebody who has the answer. Is it correct? Okay, 8a, we've got 16 minus 32x plus 24x squared minus 8x cubed plus x power 4. Then in part B, we've got 1 plus 2x to the power of 5. So that's 1 plus 10x plus 40x squared. Okay, thank you. So this is our expansion. Hence or otherwise find the coefficient of x cubed in the expansion. So that's the next part. 2 minus x power 4, 1 plus 2x power 5. I want the coefficient of x cubed. Should I expand everything out? So I've got a 16 minus 32x plus blah blah blah. Then 1 plus 10x plus 40x squared plus blah blah blah. Should I expand everything out? Well, I am only interested in x power 3. How do you get x power 3? What are the possibilities for getting power 3? Okay, so let's start. Let's do this systematically. Constant times x power 3. What else do we have? What else do we have? Right? And then a constant, which is x power 0, constant over here. Right? So how many possible ways are there to get x power 3 out? There are 1, 2, 3, and 4. Okay? So I don't want to expand everything. I only want to focus on these 4 options. Alright? So we say coefficient. Okay. Let's write down x power 3 term. Equals to, okay, first one, constant times x power 3. Where is that? Constant? X power 3, right? So right, 16 times 80x cubed. That is my first option. What's my second option? Negative 32x and 40x squared. Be very careful of the sign. So negative 32x, 40x squared. Any more? 24x squared with 10x plus 24x squared with 10x. Any more? Negative 8x cubed with 1. Okay, so minus 8x cubed. Well, you could write down over here coefficient of x cubed. Okay, then you remove all the x stuff over here. But I just want to show you. I want to show you that from here I will be able to check my work. Because over here, this is going to be giving me 16 times 80, 1280 x cubed, right? That's what we wanted. Minus 32 times 40, 1280 x cubed again. Plus 240 x cubed minus 8x cubed. To give me 232 x cubed. So now I've got an x cubed term, coefficient, equals to 232. Is that the answer? Yeah. Alright, so this is how we do this type of question. Since the bell has gone already, I will